Okay, so number 8 on the free fall sheet is Kyle in a helicopter. So Kyle is flying a helicopter when he drops a bag. The bag has fallen for 3 seconds. So it doesn't say anything about the helicopter rising in this one or lowering, so we'll assume he's flying at horizontal and that the VI is 0. And he drops a bag when the bag has fallen for 2 seconds. So delta T is 2 seconds, and A is 9.81 meters per second squared down. And so part A wants to know what's the bag's velocity, and part B wants to know, so you're looking for VI at the end of 2 seconds, and how far has it fallen. Okay, so you have a VI, sorry, you're looking for VF, I said VI there. You have a VI, a delta T, and A, and you want VF. So for part A, you would just use your equation that you've known for a while now. A equals VF minus VI over delta T. The VI is 0, so it'll just be VF equals A delta T. Everything's going down here, so you can call down positive, and you don't have to put a negative in. So it'll be 9.81 meters per second squared times 2 seconds. So the VF will be 19.62 meters per second down. Okay, that's part A. Part B wants the delta D, and if I have a VI, a delta T, and an A, I would use for part B, delta D is equal to VI delta T, 1/2 A delta T squared. Again, the VI is 0, so this term disappears. So 1/2 9.81 meters per second squared times 2 seconds squared. 2 squared is 4, half of 4 is 2, 2 times 9.81, 19.62 meters down. Now, it's a coincidence here that they're the same. Well, a coincidence because the time is 2 seconds. Because when you square 2 and take half of it, you end up back at 2. But if it was 3 seconds or 4 seconds, these two values wouldn't be the same. Okay, so that's number 8. Number 9 is Kyle in the same helicopter. Okay, so we have the same helicopter here. But this time, it says the helicopter is rising. So the VI this time is 5 meters per second going up. The helicopter is rising when he releases the bag. So delta T is still 2 seconds. Okay, A is still 9.81 meters per second squared down. And again in part A, it wants to know VF. So again, we would use A is equal to VF minus VI over delta T. Just this time the VI isn't 0. This time you have to rearrange, take the delta T up, and then take the VI over. So we'll have VF is equal to VI, which is positive because it's up, 5 meters per second. Sorry, I just flipped the whole thing around. Plus A delta T, but A this time has to go in as negative, 9.81 meters per second squared times 2 seconds. So VF is going to equal 5 meters per second minus 19.62 meters per second. So VF is going to equal negative 14.62 meters per second, and the negative just means down. Okay, so that's for part A. For part B, it wants to know how far has the ball fallen. So again, delta D is equal to VI delta T, 1/2 A delta T squared. Delta D is equal to, this time 5 meters per second times 2 seconds, plus 1/2 negative 9.81 meters per second squared, 2 seconds squared. So delta D is equal to 10 meters minus 19.62 meters. So delta D is equal to negative 9.62 meters, where again, this means down. Okay, now part C is the tricky one. Part C says, how far below the helicopter is the bag? So if we go back here, the bag has fallen down 9.62 meters. But in that 2 seconds, the helicopter has gone up. So if we look at the helicopter, assuming it hasn't changed what it was doing when the bag fell, it's going up with an average velocity of 5 meters per second, and it's had 2 seconds to do this. And so we can find how far did the helicopter go. It's just VAV delta t from our VAV equals delta d over delta t equation. Okay, so the delta d of the helicopter is 5 meters per second times 2 seconds. So the helicopter has gone up 10 meters. So the helicopter's gone up 10 meters. The bag has fallen down 19.62 meters. How far are they apart? They're apart 19.62 meters. Okay? Which happens to be the same as up here. And that's because, as far as the helicopter's concerned, the bag wasn't actually moving when it was dropped because its relative velocity, it was going the same speed as the helicopter. So someone in the helicopter's going to see the bag 19.62 meters below them, just as they would have up here. It's the person on the ground that sees that the bag really has only fallen 9.62 meters. All right, so number 10 is similar. It's just this time the helicopter is going down. Okay, so here's my helicopter again. This time, the VI for the bag is 5 meters per second down. The time is still 2 seconds, and the acceleration is 9.81 meters per second squared down. So in part A, we want VF again. So A equals VF minus VI over delta t. Rearranging like we did last time, VF is equal to VI plus A delta t. This time everything is going down. So but the helicopter, yeah, so we don't have to call down negative. So it'll be 5 meters per second plus 9.81 meters per second squared times 2 seconds. So this time it'll be 5 meters per second plus 19.62 meters per second. So this time the final velocity of the bag is going to be 24.62 meters per second, and it's down. For B, it's going to be delta D is equal to VI delta T, 1/2 A delta T squared again. Everything goes in as positive this time because everything is down. So 5 meters per second times 2 seconds, 1/2, 9.81 meters per second squared times 2 seconds squared. So it's going to be 10 meters plus 19.62 meters. So the distance the bag has fallen is 29.62 meters down. And again, both of these are with respect to the ground. Okay? And I say that because part C wants to know how far apart are the helicopter and the bag again. So the bag this time has fallen down 29.62 meters, but the helicopter's also going down. So its VAV is 5 meters per second, and it's falling for 2 seconds. So the delta D of the helicopter is VAV delta T. The delta D of the helicopter then, 5 meters per second times 2 seconds, is 10 meters, only this time it's down. So how far apart are they? They're 19.62 meters. Exactly the same as what they were in the other two. So the buddy on the helicopter is going to see the bag 19.62 meters below him just because relative to the helicopter, the bag wasn't moving in any of the 3 situations. And that was the reason why I assigned those questions, because I wanted you to see how relative velocity could look like, what it would look like with